Hello everyone. Welcome to the demonstration of data structures laboratory. Today we people are going to demonstrate the third experiment. Aim of the experiment is to design, develop and implement a menu driven program in C for the following operations on stack of integers. Push an element onto a stack, pop an element from the stack, demonstrate how stack can be used to check palindrome, demonstrate overflow and underflow situation on stack, display the status of stack and exit. Support this program with appropriate functions for each of the above operations. So this is what the aim of the experiment is. So in order to design this program, we will include an header file that is #include stdio.h. Then we will use a constant variable size. This is the size of the stack, that is the maximum number of elements we want to insert into the stack, that is 5. Then we are taking one variable called top, which is of type integer and it is initialized to -1. And we take one more variable called as I. Then we will take one array called as S, whose size is 10. So this array S, now it represents as a stack. Now here we will define the functions. So this function void display, this is to display the elements on the stack. Then the next function we will define is, we will define a function to push elements onto the stack. Then this pop function is to pop the elements from the stack. And the next function is the palindrome function. This is to check whether a given a 5-digit number or less than a 5-digit number is a palindrome or not. Then after defining all the functions, then we can define the main program. So first we will start understanding the program from the main function itself. So in the main function, we have taken one variable called as choice is equal to 1. Then it has been initialized to 1, and then we have an variable called as item. Then we are taking one more variable integer press. This is to simulate the working of stack and working of the palindrome. So here we have taken two printf statements. First one, if the user wants to check for the palindrome, then the user has to press 1. If the user is not interested in checking for palindrome, then he wants to run the simulation of stack, then the user has to press 2. Based upon the choice given by the user, the appropriate decision will be taken by the program. Now suppose that the user has pressed 1. Then if it is press is equal to 1, then the palindrome function will be called. So if the palindrome function is called, then the control passes to the palindrome function here. So here in this palindrome function, we are taking 3 integer variables, remainder, digit and count is initialized to 0. Then we are taking 3 digits, number, reverse and item, which are of type long integer. Then here we will read a 5-digit number. So we will read a integer which has maximum 5 digits. So here with the help of a scanf statement, we'll read the number and that number will be stored into item. So for that, what we will do is we will try to trace a program. We will take a simple 3-digit number and we'll check how the palindrome can be done. So this is the number what we have read. We have read it as 123. So 123 is the number, so that we are copying it into item. So item now becomes 123. So then we are having while item not equals to 0. So we are having 123 not equal to 0. So this condition is true. As this condition is true, here we people are going to compute the remainder. So remainder will be item mod 10. So item is 123, 123 mod 10. The remainder is 3. That remainder you push it into the stack. So 3 is pushed into the stack. Then now obtain item. Item is equal to item divided by 10. This is the statement we have to execute. So here we are interested in the quotient. So 123 divided by 10, the quotient we obtain is 12. Then count you increment, count will become 1. Initially at the beginning of the program, count is set to 0. Then after that, again this while statement will repeat. Then it will check whether item is not equal to 0. Now the item is 12, because here you all can see in the above iteration item has become 12. So 12 is not equal to 0. So this condition is true. As this condition is true, then again the while loop will execute. So when the while loop will execute, again the remainder will be calculated. So 12 mod 10, now the remainder is 2. So push remainder into the stack. So 2 is been pushed. Then item you calculate. So 12 divided by 10, the quotient is 1. Then increment the count, count will become 2. Then again the while has to repeat. So now we will check while 1, item is 1 now, 1 is not equal to 0. So this condition is true. As this condition is true, again the while statement will repeat. In that while, you have to calculate the remainder. So remainder is equal to 1 mod 10. So 1 mod 10 is 1 itself. Then push 1 onto the stack. Then item will be 1 divided by 10, quotient is 0. Then count will be incremented, count will become 3. Okay, then again the while has to repeat. Now you are having item is 0. You all can see here in the above iteration here, item is 0. Now we are going to check item 0 is not equal to 0. So this condition becomes false. As this condition becomes false, this while loop will terminate. So we will come out of this first while loop. Then we will execute the second while loop here. So bottom, we have one more while loop. So we have to execute that while loop. So in order to execute that while loop, we are having digit is equal to 1. We have initialized digit is equal to 1. Then after that, we have one more while count is greater than 2. So in the above iteration, count was 3. So count this 3 is greater than 0. The condition is true. So as condition is true, so this while will repeat now. We are interested in executing this while. So while entering, the count is decremented. Now the count becomes 2. Earlier, before this, the count was 3. So you can move to the previous iteration. Here you can see the count was 3. Now here the count is decremented by 1. So count becomes 2. Now we have to calculate reverse. So reverse is equal to reverse plus pop into digit. So here you all can see at the last what we had pushed at the last, just a minute. So here you can see what was the last item that was pushed onto the stack. It was 1. So pop it from the stack. So you are having reverse will be pop 1 from the stack, 1 into digit. Digit is already 1 here in this box, you can see. So the reverse value will be 1. Then print this reverse. So print reverse is equal to 1. So 1 will be printed. Then calculate the new digit. So here digit will be digit into 10. So digit will become now, digit will become 1 into 10. It will become 10. Then again the while should repeat. So you check whether the while condition is true. So you are having while count greater than 0. So it is true. Then what it will do? It will decrement the count. So count will become 1. Then after that, it will again calculate reverse. So this statement is reverse is equal to reverse plus pop into digit. So your reverse in the previous statement was 1. So 1 plus, then pop what is onto the stack. So 1 was pushed. So before that 2 was pushed. So pop 2. So it will be 2 into digit. 2 is what? 10. So this will become 1 into 20. Sorry, 1 plus 20. So it will become 21. So what you have to print now? You have to print the new reverse, that is 21. Then after that, digit will be updated. So digit now will become into 10. So in the above statement, digit was 100, 10. Now it is multiplied by 10 again. So 10 into 10, it will become 100. Then after that, again the while will repeat. So again the while should repeat. So here you have to check while count is greater than 0. So what is the count in the previous iteration? Count in the previous iteration is 1. So this 1 is greater than 0. So this while condition is true. Then what we have to again calculate reverse. So reverse will be reverse plus pop into digit. So what is your reverse? Reverse is equal to, so what is your reverse? Reverse in the previous iteration was 21, which you have recently updated. Then pop. What was pushed before 2? Before 2, 3 was pushed onto the stack. So pop that. So it will be 3 into and your digit. So digit in the previous iteration was 100. So this will become 300 plus 21. So it will become 321. So this is the new reverse what you have obtained now. 321. So this reverse what we have obtained. Now we have to print it. Now this is the reverse what you have obtained. Then again your digit should be updated. So digit will become 100 into 10. It will become 1000 because we are having digit is equal to digit into 100. That will become, earlier in the box in the left side digit was 100. So 100 into 10 it will become 1000 now. So again the while loop should repeat. Now you go while count greater than 0. So count in the previous iteration. So here the count was 0. So before entering we have decremented the count. So count was 0. So this condition has become false. So the while will terminate. Now while terminates, after that, now you have to make a decision whether the given number is palindrome or what. Now, so for that, so please check this number 321. What is this 321? This is the reverse what we have obtained and we have printed. Now, what is the number we have taken as input? Input we have taken number as 123. 123 was the number. And what is the new reverse we have obtained? The reverse obtained is 321. Then when do you call a number as palindrome? We call a number as palindrome when the original number and its reverse both are exactly same. Now here you can see the number is 123. The reverse what we have obtained by applying this palindrome function, we have obtained it as 321. Both are not matching. So here we are having a statement, if number is equal to reverse. If it is true, it will print palindrome. If it is not true, it will print not a palindrome. Now here this original number 123, it is not same as the reverse number. Hence, it will display what? The number is not a palindrome. So in this way, with the help of a stack, we can check whether a given number is palindrome or not. So this is one task this experiment 3 is doing. And in the second task is that we have to perform simulation of the stack operation. So in this program, if at all you want to perform simulation of the stack operation, the user has to press 2. And if the user want to check for a palindrome, the user has to press 1. And we have seen when a user has pressed 1, what has happened. Okay, so when user has pressed 1, we have checked for palindrome, and for a given number 123, by tracing the program, we have seen that the number is not a palindrome. Now we will see what happens if the user presses 2. If the user presses 2, it will check if press is equal to 2. So this condition is not true. It will move to the else part. So in the else part, it will, so there is one while loop here. So here it is while choice not equal to 4, until unless the choice is not equal to 4. So this statement will repeat in an infinite loop. So it will ask you to enter 1 for push, 2 for pop and 3 for display. So if a user presses 1, then the push function will be called. If the user presses 2, the pop function will be called, and if the user presses 3, the display function will be called. Now assume that the user has pressed 1, then the user has to first enter the element to be inserted. Then that element to be inserted is item. So that element you want to insert, you will put it as a parameter in the push function and you will call the push function. So when you call the push function, the control passes to the push function over here. So here we will try to analyze how the element is been inserted. Now the item what we want to insert is, say it is 12. We want to insert item 12 into the stack. So at the beginning of the program, we have taken size is equal to 5. So this is the maximum stack size we have taken. And I think you remember top was initialized to -1. Now in this push function, we will first check whether top is equal to -1. Yes, we will check, sorry, we are not checking it with -1. We are checking with top is equal to size -1. What is your size we have taken in the program? It is 5. So 5 minus 1, it becomes 4. Initially in the program, top is how much? Top is -1. So -1 is equal to 4. This becomes false. So this if part will not execute. So we'll come down here and here it will increment top. So top will be incremented. Top will become 0. So here it will try to insert the element into the stack. So we will try to construct an array or stack of 5 elements. So this is what the array we have taken. So here top is equal to 0. Top is equal to 4. So if we check before pushing the element, we check whether top is equal to size -1. So here we have obtained as false. Then top is incremented, top has become 0. Then what it will do? At S of top, it will insert item. So what is the item? Item to be inserted is 12. So top is 0. So at 0 position, 12 will be inserted. After that, it will call for the display function to display the element. So that display function, we will see it later on. Now once again, say if at all I want to insert the element, now say I want to insert the element, say 24. So same way again it will check whether top is equal to size -1. So size -1 means 4. So top is equal to 4. The condition is false because top is equal to 0 now. Okay. So top is equal to 4. So this condition is false because top was 0 there, but we are checking whether top is equal to 4. So this condition is false. This indicates that the stack is not full still. So we can try to insert. So what it will do? Top will be incremented. Top will become 1. So at 1, it will try to insert the next element, that is 24. Then again we want to insert one more element. So again it will check if, say we want to insert item, that is 50. We want to insert item 50. So again while inserting item 50, again it will check if top is equal to size -1. So top size is still 5 only because that is the maximum stack size. It is 5. So top is equal to 4. This condition is false because after inserting two elements, top is 1. So top is equal to 4. This condition is false. So again we will try, it will increment the top. So top value will become 2. Then the third element will be inserted into the stack. So 50 will be inserted. In the same way, we will insert the fourth element into the stack. So the fourth element we want to insert is 80. So we have taken item is equal to 80. So again it will check if top is equal to stack size minus 1. So it will check size minus 1. So 4. So this condition is again false because top is equal to 2 and the size minus 1 is 4. So it is false. So again we can insert the element. So top is 2. So we will insert element 80. After that, we want to insert one more element, that is the fifth element we want to insert into the stack. So fifth element, what we want to insert is, it is say 45. So for that, again it will check whether top is equal to size minus 1. What is the top now? Just a minute. When we inserted 12, top was 0. When we inserted 24, top was 1. When we inserted 80, 50, the top was 3. Top was 2. Then when we inserted 80, the top was incremented. Top has become 3. After that, now we want to insert the fifth element. Item is equal to 45. So again you will check whether top is equal to size minus 1. So this condition is false now because size is 5, size minus 1 is 4, top is 3, 3 equal to 4 is false. So what it will do now, top will be incremented, now top will become 4. So at S of 4, the fifth element will be inserted. Now say we want to insert the sixth element, so item is equal to say 100. So we want to insert item 100 into the stack now. So what will happen now at this stage, whether the item will be inserted, the item will not be inserted. Why? It will check if top is equal to size minus 1. So size is 4. So when we inserted item 45 into the stack, what was the top value? Top value was 4. So this top is equal to 4. This condition is true. As this condition is true, it will print overflow. Okay, so it will print overflow indicating that the stack is full. So as top is equal to 4, this condition is true. So this indicates that the stack is full. Okay, so as after we inserted all the 5 elements into the stack, when we try to insert the sixth element, it will show that the stack is full. So this is how the push operation can be performed. Okay, now we'll try to see how the pop function works. The pop function is used to delete the elements from the stack. So for how the pop function will be called, for calling the pop function, the user has to press 2. So when the user presses 2, so here it will display the popped element is, and then the pop function will be called. So when the pop function will be called, the control passes above to the pop function, and here we'll try to analyze how this pop function works. Now we will take the same old array what we have taken. So there are 5 elements here. So what is the top value now? Top value is 4. So as we have learned in the stack module, that while inserting the elements, the stack should be top pointer should be incremented, and while deleting, the top pointer should be decremented, and while deleting you should check whether the stack is empty. So what is the top value now? Top is 4. So you should check whether it is equal to minus 1. So top value is 4, whether it is equal to minus 1, no. So this condition is false. So what it will do, what is there on the top of the stack, it will be copied into T. So T will become 45. So 45 will be deleted. 45 is deleted. So after deleting, the top value will be decremented by 1. Top value will become 3. So again, you will check whether top is equal to, again after deleting one element, you will check whether top is equal to minus 1. Again, the condition is false. So 45 is been deleted. Now the top value is 3. So which is the element we want to delete now? We want to delete the item that is 80. So 80 is deleted. So after deleting, the top value will be decremented. Top value will become 2. Okay, so 80 is been deleted. Then after that, again you should check whether the stack is empty. So again you'll check whether top is equal to -1. The condition is false. So now the top value is 2. At 2, what element we have? At top is equal to 2, we have 50. So 50 should be deleted. So it will display 50 is deleted. So 50 is deleted. Then again, after deleting element 50, again check whether the stack is empty. It is not empty. So top will, now it will delete what is on the, after deleting 50, top should be decremented. Top will become 1. Then after decrementing top, check whether top stack is empty. So for the condition to check the stack is empty, it is if top is equal to -1. Now again it is false. So what? You have to access the element at 24. So at top is equal to 1, we have an element 24. So we have to print 24 is deleted. Okay. Then top should be decremented. Now the top will become 0. So 24 has gone from the stack. Then after deleting the 24 element, now again you'll check whether the stack is empty. Still top is 0, it is not equal to -1. The stack is not empty, so the condition is false. So now what you have to access? You have to access the element at position 0. So that the position 0, we have element that is 12. So 12 is deleted. So after deleting the element 12, top should be decremented. So as top was 0, after decrementing by 1, top will become -1. Now if you try to delete the element for the 6th time, now the condition top has become -1. So -1 is equal to -1. This condition becomes true. As this condition becomes true, what it will print? It will print underflow. Underflow indicates that the stack is empty. When the stack is empty, the deletion is not possible. Okay, so this is how the elements in the stack can be deleted. The next thing is that we want to display the elements in the stack. In order to display the elements into the stack, we have a function called as display function. We'll try to analyze it. So we'll check the same array. Okay, so here there are 5 elements into the stack. So top element is at the 5th element, that is 4. Now, while displaying, you have to check whether the stack is empty. So for that, you will check the condition if top is equal to -1. So this condition is false. That indicates that the stack is not empty. Then here we have to print the contents of the stack. So contents of stack are. So in order to print the contents of the stack, the control passes to this part of the program now. So here we are having a for loop. So we'll take for I is equal to 0. So we'll take for I is equal to 0. Then you'll check whether I is less than or equal to top. So what is your top now? Top is 4. So I is 0. 0 is less than equal to 4. So this condition is true. So what it will do? It will print the element at I is equal to 0. So what is the element at I is equal to 0? It is 12. So 12 will be printed. Okay, after that, as it is a for loop, now I value will be incremented. Now I value will become 1. I was 0, now I will become 1. 1 is less than equal to top. The condition is true. So at I is equal to 1, what do we have? We have 24. So 24 will be printed. Then again the for loop will repeat. Then I value will become 2. Then at I is equal to 2, what is the element that we have? At I is equal to 2, we have the element that is 50. So 50 will be displayed. Then again the for loop will repeat. I value will be incremented. I value will become 3. 3 is less than equal to top. The condition is true. So what is at I is equal to 3? We have 80. So 80 will be printed. Then again the for loop will repeat. So again the for loop will repeat. I value will become 4. So 4 is less than equal to top. Condition is true. What is at I is equal to 4? We have 45. So 45 will be printed. Again the for loop will repeat. Now the I value will become 5. 5 is less than equal to top, here the condition becomes false. So as the condition becomes false, the for loop terminates. Okay, now the for loop will terminate. Now what we have seen, there were 5 elements in the stack. All those 5 elements are being printed. So first 12, then 24, then 50, then 80, and then 45 was printed. So this is how the program on stack to push elements, to pop elements, and to the display elements, and to find palindrome of a given number can be implemented. Now we will try to execute the program. So for that we will open Turbo C here. I have already kept the program typed. So just open Turbo C there. Then just open the program. Okay. Now run the program and check whether there are any errors. Now there were no errors in the program, so the program has directly executed. So say I want to check for palindrome, so I have to give 1. Then it is asking me to give a maximum 5-digit number, so I'll give input as 1 2 3 4 and I'll press enter. So what the program will do now, it will print one by one whatever the reverse is been obtained. So first the reverse obtained is 4, then 43, then 432, and then 431. So step by step the reverse how it is been obtained, that reverse is been obtained here, and that reverse is been displayed here. Then the lastly the reverse what you have got is 4321. The original number what we have read was 1234. So the original number and the reverse both are not matching. Hence it will display a statement that 1234 is not a palindrome. Okay. Now we will once again compile the program. There are no errors. So once again we will run the program. Just a minute, it has got stuck. Once again open Turbo C here. There is some technical issue, just a minute. Now we'll open the program, that is program3.c. We will just open it. Okay, so we'll compile the program. There are no errors. Then we'll run the program. Okay, there are no errors. Run. Now we will press 1 and we will give number 1221. So 1221 should be a palindrome. Now we'll check what the output would be. Now the output is 1221 is a palindrome. So this is how using a stack the palindrome can be implemented. Now next, again we'll run the program. Now we'll perform simulation of the stack. So in order to perform simulation of the stack, we have to press 2. Then 1 for push. So I want to insert element 20. Then the contents of stack are 20. Once again I will push the element. Say I will push 30. So contents of stack are 20 and 30. Once again I will give 1 and I'll press one more element, that is 45. So the contents of the stack are 20, 30 and 45. So once again I'll try to push. So I'll enter 56 now. So the contents of the stack are 20, 30, 45, 56. Then once again I'll push the element. Now this time I am reading 80. So 5 elements are being pushed. Now I'll try to read the sixth element. So sixth element, suppose I have read it as 96. Then if I try to read the sixth element, it will give overflow. Okay. Now it indicates that the maximum size given is 5. So it will enter only 5 elements. So now we will display. For displaying, we'll give 3. So these are the contents of the stack. Then we will try to pop the element one by one. So for that, we have to enter 2. So popped element is 80 because on the top of the stack 80 is there. So the element that will be inserted last will be deleted first because stack is last in first out data structure. Now one more element will delete, which is 56. We'll again display and check whether the elements are been deleted or not. Earlier we had 5 elements, 20, 30, 45, 56, 80. You can see on the top here there were 5 elements. Now we are left out with only 3 elements because 80 and 56 already are been deleted. Now again we'll pop 45. Then again I'll press 2 and will delete 30. Again I'll press 2 and will delete 20. So all the elements are being deleted. Now it is showing the elements of the stack are empty. That is, this is how the operations on the stack can be performed. Now I want to exit the program. So press 4 and terminate. So this is the program using C to perform operations on stack. So thank you very much for patient hearing.